Unit 4, topics 4 and 5, Venn diagrams and set operations. What's kind of cool about these is it's nice to visualize. You can draw pictures, or it's a little bit different than some math. It's a little bit harder to visualize. So we'll go through an introduction for both. The homework assignment for these sections are separated. So you're going to have a homework 4 and a homework 5, but the lesson here is combined. So the idea, this is a combination of two topics, Venn diagrams for sets and their operations. In these topics, we will be able to look at multiple sets in a visual form of understanding, which is kind of what I just said. A set that has all elements we are interested in is a universal set. For example, if we were grouping your Facebook friends, the universal set would be all of your Facebook friends. Now, we might consider subsets like based on age or gender, but the universal set would be all of your Facebook friends. If you were working with any set of numbers, the universal set might be all whole numbers, all integers, or all real numbers. Again, it's all the numbers that you're interested in. The complement. The complement of a set A contains all of the elements not in A, given the universal set U. Some examples. Suppose the universal set U is equal to all whole numbers from 1 to 9. So then if A was 1, 2, 4, then the complement, see how that's noted A to the C kind of, that complement would be all the other numbers, 3, 5, 6, 7, 8, and 9. So the complement is all the numbers that are in the universal set that are not in the set A. Here's an example. If the universal set U is equal to A, 1, B, 2, C, 3, D, 4, E, and 5, and A equals A, 3, D, 5, what is the complement? Well, let's take a look. See if I can make this so we can see them together. There we go. So the complement, remember that's notated A, C, would equal, so let's see if it goes, so 1, B, 2, C, not 3 because 3 is here. Oops, yeah, 3 is here. D is also there, so we don't want to include that in our complement. 4 and E, and 5 is there, so we don't want to do that. So that would be the complement of A in that situation. So again, it's just anything that's not in that set, that's in the universal set. Let's go down. Okay, unions and intersections. So you can see the writing's real great on here. I have a hard time writing on this, so please, disregard the horrible penmanship. The union of two sets A and B contains all the elements contained in either set. So let's say that we had, well, we'll go through an example in a minute, but the notation is A, U, like that, B. It's not a U, it's just kind of like a U without this, the other part. But the way I always thought of it when I learned it is it looks like a U, so you think it means union. So this is A union B. Then the intersection of two sets contains only the elements that are in both sets. It's where they intersect, okay? So that would be A intersect B, okay? So here, let's have an example. So we say let A equal the set of letters in the word arithmetic and B equal the set of letters in the word metrics. So that would mean that A equals A R I T H M E T I and C, right? I believe that's all of them. And then B would equal the letters M E T R I C S. Now, if we were to draw this, I could do something like this. Although I'm probably not going to be able to fit it all in there perfectly. So let's say this is A. So we have A, which is only in A, and then we have R is in both, right? I is in both. T is in both. H is in A. M is in both. E is in both. C is in both. And I think S is the only one that's in B only. Is that right? Metrics. Yes, I believe so. Okay. So then when we're looking at our part I here, we have A equals, well, we already defined that. So there's our A right here. That's part I. Part double I, 2 right there. That's the B. So now let's go ahead and find, oops, A intersect B. That's the part in the middle where they intersect. So we have R, I, T, M, E, C. All right. Now I'm running a little bit out of room, but let's see if we can do the union. It's going to be, let's do this up here. So the union is all the letters that are in there, right? So we have A union B is going to equal, and we just basically write all the letters, not duplicated, but all the letters that occur in both. So we have A, H, R, I, T, M, E, C, and S, because we have that S over here in our B set. So again, that's the union is all the letters that are in both sets. The intersection, excuse me, that's not the right word, is it? The union is all the letters that exist in either set. The intersection is the letters that exist in both sets. So that would be this area in here. And the union is all of this, right? Okay. Let's look at another one down here. So let's go down to Venn diagrams, which is what I just drew, but again, we weren't really talking about that yet, but I think it's such a great way to visualize it. So we're going to reiterate what we just talked about. A Venn diagram illustrates the intersection of 2 or 3 sets represented by circles. These circles are inside a box, which signifies the universal set. So you see here, this box would be considered our universal set, and these would be our different sets. So you can do 2 to 3 different sets and show the intersection, and not necessarily the union, but you can visualize the union by seeing what's in all the circles. So here's an example. Let's go ahead and draw our diagram here, and then I'll show you both together. So we're given A, don't worry, I'm going to show it in just a sec. We're given A equals that B3, DE 5, and B equals 5D, 6B, and 7. So let's go ahead and draw our diagram. We have our universal set here. And our 2 circles. So if this is A, I'm just writing this, you don't have to write this, but I want to make sure it's very clear which is which. So we have B, which is only in A. We have 3, which is also only in A. We have D, which is in both. We have E, which is only in A, and 5, which is in both. And then in B, we have 5 already, 6, B, which we already have. Oh, wait, I forgot about that. Sorry, that was in the wrong spot then. I missed that. Let me just double check. So we have B and D in both. So we have B, 3. Okay. So B is in the intersection, and then we have 7. So as you can see here, this part in the middle, that's our intersection. That's what we would consider A intersect B. Okay. All right, so that's how we do a Venn diagram. Here's a set with 3. So let's take a quick look at that. Let's see, this is horribly not to scale. And see, what's kind of cool here is you have different intersections. So let's see what we can find. Okay, so let's look in A. So we have 2. Do any of the other ones have 2? Nope. Oops. Just A, B, C. So we have 2 up here. 4. 4 looks like it's in A and B only. So that means it's going to go here in the A and B intersection. So here we have the A-B intersection. Here we have the intersection of all 3. So you have different intersections. So since that 4 occurs in the A and B, you want to make sure it's in that A-B intersection, okay? So then we have 6. 6 is in A and B also. 8 is in A and C. So where's our A and C intersection? Our A and C intersection is right here. So that means we have 8 there. 10 is only in A. All right, so let's go over to B. So far we have 4 and 6 that were also in A. Now we have 12. 12 is only in B. And then we have 14, which is only in B. So let's go over to C. We had that 8 that was already in A. And then we have 15, 17, and 19. 15, 17, 19. Okay, so that's it. So you can see the different interactions or the different, right here. So here we have the different ones. So this is, we have A intersect B equals 4 and 6. And then we have A intersect C equals just 8. And then you notice there's no other intersection over here for either A intersect B intersect C. So that means it equals null set. And then same thing for B intersect C equals the null set. All right, so let's see. All right, that's it just for introducing the Venn diagrams and set operations. So now we've learned about universal sets, intersections, and unions. And in the next videos, I'll go through a few homework examples. So if you have any questions about the basic concepts, let me know.